In a few short months, the amazing pictures taken by the James Webb Space Telescope changed everything we knew about the universe. The JWST is the biggest telescope ever put into orbit. On July 11, 2022, when it finally started taking pictures, we saw them for the first time. And they were beautiful. Huge dust and gas landscapes in space and the deepest parts of the universe were seen for the first time. There were big galaxies that were interacting with each other and stars that were getting close to dying. But even the most amazing pictures only show the tip of the iceberg melting into data that will completely change how we think about the outside world. Join us as we look into the James Webb Space Telescope's scary new picture of city lights and how it has shocked the whole world. This is possible because it takes a long time to travel across our universe, like billions of years. When it gathers this light, the JWST looks at these things as they were billions of years ago. Astronomers measure distances in light years, which is the farthest light can travel in a year. This is something that the team's first graphic made sure to point out. SMACS 0723. Galaxy SMACS 0723 is 4.6 billion light-years away, and its huge gravitational pitch makes the galaxies behind it look bigger. Where the gravitational field is strongest, the galaxies in the background are bent into large arcs. In one case, it was found that it took light from a galaxy 13.1 billion years to travel through space and reach the telescope. Because the galaxies are so far away, the light they give off is spread out as the universe grows. The James Webb Space Telescope's main targets are galaxies that have stretched visible light from their stars. By getting data at these wavelengths, astronomers can directly compare what the JWST sees with what Hubble and other observatories saw when they took pictures of nearby galaxies in visible light. This will show how galaxies evolved throughout the course of cosmic time, growing larger and more consolidated into the formations that we view today. Even more amazing than the fact that the JWST's first deep field image shows a huge number of galaxies is the fact that it was taken in only a few hours instead of months. It seems likely that galaxies will be found almost everywhere it looks. The only things in the universe that can act like magnifying glasses are a group of galaxies. The JWST took a picture of a pair of galaxies called VV191 so that scientists could study how the light from one pair changed as it went through the other. The results of the study will show what kinds of things the galaxies are like that are between the pairs. There are galaxies and black holes in the universe. STEPHAN'S QUINTET. One of the first pictures the JWST took was of STEPHAN'S QUINTET, a group of 5 galaxies that are close to each other. Because they are so close to each other, the 4 galaxies in this group are affected by each other's gravity. The 5th galaxy in this group looks close, but it is actually much closer to us than it looks. It just happens to be in our line of sight. Together, the galaxies that are interacting with each other make a lab where astronomers can study how galaxies interact with each other and merge. These kinds of mergers are thought to have happened a lot in the early universe. It is thought that the mergers, which were the main way galaxies grew into the huge star cities we see today, also led to the growth of supermassive black holes, of which there is one at the center of every galaxy right now. Using the JWST's NeoCam and MIRI sensors, scientists are looking into the STEPHAN'S QUINTET. Astronomers were surprised by the pictures taken by the MIRI spacecraft because the shapes of the galaxies were not what they had expected. The ghost galaxy M74 was found by the MIRI instrument, which was another amazing find. M74. A spiral galaxy at 32 million light-years from Earth, the huge spiral arms that give spiral galaxies their name are almost facing us. Because of this, it is a distance that is often used to study spiral galaxies. No one has ever seen it so clearly before. For the first time, the spiral arms of the galaxy where stars are being made can be seen extending down into the center of the galaxy. Collaborations will be a key part of fusing the JWST's new observations, and this will be the first time that this has ever been possible. With those from existing galaxies, they'll get a deeper understanding of the astronomical objects being studied, as well as the new discoveries that everyone hopes the telescope will make. One area where infrared astronomy shines is in looking deep into the clouds where stars are formed. This is because dust, molecules, and atoms are less likely to scatter light at longer wavelengths. In fact, at infrared wavelengths, all of the things that make it hard for us to see the stone nurseries become clear. The camp looked at the star-forming region NGC 3324 in the Carina Nebula, which is about 7,500 light-years away. This is where the translucent and other images were taken with the JWST. It's great that you can now use infrared to look inside the Carina Nebula, which looks like a landscape even though it's just gas and dust being shaped by starlight. The Carina Nebula is a beautiful sight to behold. When it was first found, it was called the Cosmic Cliffs because the huge gaseous cliffs looked like a melting mountain range. It was actually the edge of a huge hole that was slowly being worn away by the strong ultraviolet radiation from young stars, foundations of the world. One of the most famous pictures taken by the Hubble Space Telescope is of what are called the Pillars of Creation. JWST has recently used its NeoCam and MIRI instruments to study this same area. It lets us see deeper into the huge star nebula than it has ever before. These are parts of the Eagle Nebula, where the new stars are being made. The Eagle Nebula is a much bigger cloud of interstellar gas. One of the best things about the photos are these phonetic bright orange things that sometimes show up at the tips of the fingers. These shock waves are caused by young stars that are just starting to use nuclear fusion to make energy. Huge jets of material are shot out, and when they hit the dusty cocoon that each star is wrapped in, they blow it away and show the star to the rest of the universe. Due to their lack of brightness at these wavelengths, switching from the near-infrared image to the mid-infrared region of MIRI shows a similar but strangely different landscape. At this point, almost all of the stars have been wiped out. The dusty pillars are now being lit up by emissions from naturally occurring substances like polycyclic aromatic hydrocarbons. The most interesting thing about them, though, is that sometimes you can see bright stars at the tips of the gaseous fingers. These bright stars are the young stars, and each of them may have its own solar system of planets. With the JWST's new views of the Pillars of Creation, scientists will be able to test what they know about how stars form and improve their computer simulations of the process. This is because the JWST will give them more information than ever before about how galaxies replenish their ability to make stars. Even though they have always known this, the MIRI team was surprised to see the results. You need to know as much as you can about how many young stars are in these areas, how the masses are spread out, and how much gas and dust make up the nebula at the other end of the stellar life cycle. The JWST has also given us more information about how stars die. Sun-like stars grow bigger and turned into big red stars. Then they shrank and died, becoming white dwarfs, which are dead stars. During this collapse, they break up and throw off their outer layers, making a planetary nebula, which is a horribly wrong idea. In the picture taken by the JWST, the Southern Ring Nebula shows how beautiful this process may be. That was all from our side. Stay tuned for more.